This is the tutorial for Chapter 6, Section 5, Analyzing and Sketching Graphs, day number 2. So let's take a look at it. Here's a matching problem. And so we've got these different graphs, and we've got speed on the y-axis, time on the x-axis. So it says for letter A here, you gradually increase your speed. So increasing your speed, it could be one of three. So we're increasing speed here. Speed's increasing with time. Here, speed's increasing with time, and speed's increasing with time. So we have to read further. It says, then write at a constant rate of speed. So constant rate of speed is going to end up being a horizontal line. And so whenever I see that, I know I've got that horizontal line, and so it gives it away that letter C is the answer for this one right there. And so we'll finish that word off there, horizontal line. Letter B, it says you gradually increase your speed, then go downhill. So when you go downhill, you end up going faster. Well, if you're going faster, that means the line needs to be steeper. And so that's a key word there for a steeper line, and that's what I see here. So we're increasing our speed, then we go downhill, and that's going to end up making us go faster. And so I'm going to go with letter A for B. And then you gradually increase your speed, then stop at a store for a couple hours. Okay, so we gradually increase our speed. Now, they didn't say, but then when we go to the store, we have to slow down. So we couldn't just go to the store and then automatically stop. So you have to have this descent, and then this is where we stop for a while. And so we stopped and rested, so we would say letter D goes with letter C. And the last one, you ride a bike at a constant speed, then go uphill. Uphill means you go slower, and so it's going to slow you down, and so that's what we should see here. So you're riding your bike at a constant speed, flat line there. Then we go uphill, so that's going to make us go slower. And then once we get to the top, we gradually increase our speed, so that matches letter B. So let's take a look at some other problems. So we are reading the problems and trying to draw the graph. And so let's take a look at the first one here. Sketch the graph that represents the situation. A stopped subway train gains speed. Okay, so we're talking about speed. So we're going to sketch our coordinate plane, just the x and the y axes. We're going to call speed the y axis. And since we're dealing with speed, we'll go with time as the x axis. So a stopped subway train gains speed at a constant rate. Okay, so constant rate means it's going to be going uphill. The line will, so we're getting faster as we're going at a constant speed until it reaches its maximum speed. It travels at this maximum speed for a while. Okay, so it's traveling for a while at the maximum speed, and then it slows down at a constant rate and comes to a stop at the next station. So it slows down at a constant rate. This means it needs to be a line that continues on, and so it stops at that spot. So look at the next one. A fully charged battery loses its charge at a constant rate until no charge is left. Okay, so from there, they're talking about the charge of the battery. So we're going to call the y-axis, the charge of the battery. And then we'll call the x-axis time. As time increases, the battery is going to charge when it's being charged, and then it's going to decrease in charge after it's stopped being charged. So a fully charged battery loses its charge. And so we're going to start up here. Maybe this is the full battery and full charge, and then it loses its charge at a constant rate. So constant rate right there, so we've got a straight line until there's no charge. Okay, so you plug it in and recharge it. Okay, so right after it's been charged, let's say as soon as it drains, we're going to plug it in. As soon as we plug it in, it's going to begin to charge. It's not going to be fully charged until a certain amount of time. Well, once it hits that fully charged mark, well, we're going to unplug it and we're going to use it, and it's going to discharge its energy, and eventually it will not be charged anymore. And so that's what we end up seeing. So here it talks about as television size increases, the price increases at an increasing rate. And so we're going to start with the cost along the y-axis. So that's what we're comparing. We're comparing the cost to the television size, so TV size. And so it says the price increases at an increasing rate. So it starts low and it's getting higher, but it increases, the price does, at an increasing rate, so we know we're dealing with a curve. And so that curve needs to bend up so that the cost goes higher. It seems to get higher as the TV size still continues to grow, but eventually you're not going to have a TV size that is astronomical big, so that means that eventually it'll end, but this is kind of what the curve ends up looking like. So on this next one it says, as the available quantity of a product increases, the price decreases at a decreasing rate. So we'll go ahead and sketch the coordinate plane. And on this one they're talking about the price, the availability of the quantity, the product, the price decreases. Okay, so they're comparing price here to the available quantity. So we'll put the quantity of product. And then we'll go ahead and start our chart. Now it says that as the availability of the price increases, so this part is getting bigger, the price decreases at a decreasing rate. So we're going to start high, and it's going to, at a decreasing rate, tells us that we're going to end up having that curve, and it's going to come down like this. So let's take a look at the next problem here, and it says, after takeoff, the altitude of an airplane increases at a constant rate. Okay, so let's go ahead and sketch in a line for the y-axis and the x-axis. And we'll say that the altitude represents the y-axis, and we'll go with time as the x-axis. And so we're comparing altitude to time, and it says at takeoff, so we're starting down at the origin here with no altitude, the airplane increases at a constant rate. So constant rate tells me I've got a line now that remains constant, so at a constant altitude for a period of time, and then decreases at a constant rate until it lands. So there it lands on the ground. So the next one says you gradually increase your speed at a constant rate over time. And so we'll start at this point here. So you gradually increase your speed at a constant rate over a period of time. So let's take a look at what that'll look like. So we'll start with our coordinate plane. And they're talking about speed, so I'll put speed on the y-axis, and I've got time on the x-axis. And it says we gradually increase our speed at a constant rate. So gradually means that it's not going to be as steep. So not steep. So make sure that that line is under a 45-degree angle. And then it says you come to a steep section of the hill. Okay, so rapidly increase your speed. So it's going to end up going up much quicker. And then at a constant rate again. So at a constant rate means that we're going at a straight line, and then you decrease your speed until at a constant rate until you come to a stop. And so then you just kind of gently decrease your speed, and you've stopped at that point. So over here it says you gradually increase speed. Okay, so let's go ahead and set up another one. We'll put speed along the y-axis, time along the x-axis. You gradually increase your speed. And so again, it's not very steep. And at a constant rate over time, but fall about halfway down the hill. Okay, so we fall. Now, as we fall, we're not going straight down. You don't instantly stop, but it's going to be a very steep line. So it's not going to take you long to stop. And so that's going to be our fall, and then you take a short break. Okay, so we take a short break, so we're right along the x-axis. We have not moved at all. And then you get up and gradually increase your speed again. So fix that part there. So we get up and gradually increase our speed again. So it'll look very similar to the last. So those are the types of problems that we're going to see on tonight's homework and book.